Okay, so this is the JFlap application. There are a lot of things you can do with this application. You can model your finite automation. You can model a mini machine, a more machine, a push down automation, turing machine, and the likes. I hope to be able to get to push down automation with you guys before your exam. Most probably we should get to that point before the exam. So back to the question for today, the vending machine problem. So let me just put this on one side so we can always have to see, you can always get to see it. You need to check it again. So let's start. I'm going to click on finite automation. So the environment for finite automation then loads up at this point. So let me try and increase it for view. Okay, great. Okay, good. I think this is just fine. Now to model this machine, the first thing that should come to your mind is how much is the cost? What's the cost of an orange? Now that tells you that from the initial point. Now once you click on the state, once you click on the cube, which is state, it brings out each state. So if you continue clicking, if like that, it brings out different states for you. But let me just list the place. Let me just put all of this somewhere. So don't worry yourself about them for now. I'm just trying to show you the tool. So, and you can always edit each state. If you right click and click on settings, you can then change this to whatever it is you want to change it. So I can call this QF if I so desire to call it QF. So let me call it Q. Let me put it a little bit far. Now, if I need to then show a transition is right here on top. So if I click on transition and I click on the state, then no, I shouldn't. I'm supposed to drag it. So if I click on the state and I drag it to another state, then it tells me what is the alphabet that takes us from Q0 to QL. So now I'm taking my Q0 to be the initial state, and I'm taking the QL to be final state. So irrespective of any amount I give to it, at the point where the machine says a 5 naira, it should give me an orange. Of course, I need to designate this as an initial state. So to designate this as an initial state, I'm supposed to first click this. So I'm supposed to right click. If I right click and I say click on initial state, it marks this as an initial state. So if I right click on the QF and I label it as final, it marks it as a final state. So let me just switch it up a little bit just to give me more room for design. Okay, so irrespective of whatever it is, how the combination of coins or money I give to the machine, at the point where I give it 5 naira, it's supposed to give me an orange. Now let's now consider the other options. Now, what if that's the easiest thing you can do, to give the machine 1 naira? That's the easiest thing you can do. But let's consider another situation whereby you gave the machine instead of giving the machine a straight 5 naira, that you give the machine 1 naira, 1 naira, 1 naira to 5. So watch that. I'm trying to solve the problem first by trying to solve the easiest things first. After that, then I'll then increase the complexity. But to solve the problem, try and do the simple part first. Do the simple things. That way you reduce complexity. So let's assume I have Q1 here now, and if I give my machine one error. I want it to come to state Q1. Let me bring another one up. Excuse me. So let me bring this up here. Let's say that from state Q1, if I give a machine another one error, I want it to go to Q2. So like that, I've given the machine just 2 error. Obviously, you're not going to give me the orange because that's just 2 error. I'm supposed to have 5 error. Let's assume I have another state Q3, and at state Q3 also, I give my machine 1 error from state Q2. That's a total of 3 error altogether, still up to 5 error. So let me, I keep making this mistake. Excuse me. So state Q4 now. If I give my machine again another 1 error from state Q3, that's 1. That is 4 error altogether and 1 error short. Now, at the state where I've given the machine 4 error, if I give it one more coin from 1 error, that is, am I supposed to create another state for Q5? No, because at that point, it's having 5 error altogether. So if that happens, I'm just supposed to take it to my QF at 1 error. So if you want to count it, 1, 2, 3, 4, and 5. So we've arrived at the same final state, just as we have when you give the machine a straight 5 naira. Two simple scenarios, but don't forget, what if I didn't do 111 or I didn't do or I give 2 naira? So let's now start. Don't forget that every time you start, you have to start from the initial state. Every time. That's why it's called initial state. You can't come and start from K1 except you designate K1 as a final state, as the initial state. Of course, you can't have 2 initial states on the machine. An initial state must always be the same state that you define as initial state. So, again, let's start. Now let's continue. So, for me, if I give my machine, don't forget that the first question I'm supposed to even ask you is, what is the alphabet of this machine? What is the alphabet? The alphabet is 1 error, 2 error, and 5 error. The alphabet are the inputs, and by definition, alphabet are the input symbols that are acceptable on a machine. If somebody comes with let's assume there is a 10 error coin or a note, and you put it inside this machine, should it accept it? No, because we didn't define it as an alphabet for this machine. So alphabet is very, very important. What is supposed to be accepted on a machine? Same thing with your ATM machine. If what are the alphabet of the ATM machine? Of course, you have the letter 1 to 0. 0, 1, 2, 3, or 0 to 9. Let me call that 0 to 9. Then accept, correct, cancel, all those buttons all around. If somebody comes and put alpha, should they accept it? No, because alpha is not part of the alphabet of the machine. Alpha is actually from the Greek alphabet anyway. So let's continue. As state Q note. What if someone decides to give a machine 2 naira? What should happen? Well, maybe you guys guessed it correctly, I don't know, but the right thing is, ask yourself, do we have a state that has 2 naira already? Yes, which is state Q2. Don't forget initially when we did 1, 1. At this state Q2, machine already has 2 naira. So let's say at this point, what if you now give 2 naira, like you might write a guess? Then let's come to Q2, because that's the state that is saying 2 naira. Now, there's a check here. From my keynote, I've implemented all possible alphabets. All possible alphabets for my machine. Now, I have 1 error coming out of K1, I have 2 error coming out of K1, I have 10 error coming out of K1. Then I'm saved on K1. Nobody can come and then put an alphabet that's accepted, and the machine will not know where to go. That's not a good design. Your design must always have all the alphabets represented from all the states. Now, this is fine. Let's go to my Q1. At Q1, I already have one going out. What if I give my machine 2 naira at Q1? What should it go to? Don't forget that at Q1, we already gave the machine 1 naira already. So if I give it 2 naira now, that will be 1 plus 2, that will be 3. Do we have a state that has 3 naira already? Yes. Q3, 1, 2, 3. So for me, if I decide to give my machine 2 naira, let it go to Q3. What is 2? But okay, so for it to be visible, let's drag it a little separate. So you can see it here. Now you can see it now. You can do a bit more clearer. You can see that at state Q1, when I get my machine 2 naira, we went to state Q3 because 1 plus 2 is 3. Then am I saying on Q1? No. What if someone decides to after giving the machine 1 naira, decides to give the machine 5 naira? What should happen? 1 plus 5 is what? 6. So where should the machine go to? The machine should actually go to the final state because you already gotten to the amount you needed. But we have a condition to say that the machine does not give change. That means that it will give you your range, but you just forfeited your 1 naira now. You could have just given it 5 naira from here. But then all the same, this can happen. So that is well represented. Now let's look at Q1. 1 is already going out of Q1, 2 is already going out of Q1, 5 is already going out of Q1. We are safe on Q1. So nobody can come and hack our system at Q1 also. Let's move to Q2. We have 1 already coming out of Q2. What if we give the machine 2 naira again from Q2? What should it go to? Of course, at Q2 we already saw 2 naira. So if we give it 2, that will make it 4 naira. So it should go to state Q4. So that's at 2. And now, what if we give the machine 5 naira at Q2? What should happen? Of course, that will be 2 plus 5, that's 7. Machine will obviously go to the final state because you'll be using 2 naira. And that's what we've done over there. Now, now let's go to Q3. At Q3, we already seen 3 naira. Anyhow you do it. Either you take a 2 naira from Q0, which takes it to Q2, and you take a 1 naira from there, it will take it to Q3. Or either you take a 1 naira from Q1, and you take a 2 naira from Q0, 1 naira from Q0, then 2 naira from Q1, that will give it to Q3. We're fine. So if we take 1 naira from Q3, it takes it to Q4. What if we take 2 naira from Q3? That will be 3 plus 2. That will be 5. So what should happen? Final state. What? So of course, don't forget you can also now. What if somebody then also gives the machine 10 naira at Q3? That will be 3 plus 5. That's 8. Of course, you get your own range, but you don't get your change. So we do it again. So you have 5 there. That's all. So that's why it's tag bits on top of it. 2 and 5. So we'll continue this. It's almost 15 minutes. I need to stop this video. We'll continue in the next video.